Imagine right before your eyes a colossal fiery celestial body, with a mass millions of times greater than our Earth, proudly radiating its brilliance amid the endless night sky. Yet, in a mere cosmic blink, all that grandeur is torn apart and devoured by an invisible monster. This scene might sound like the wildest science fiction nightmare, but in reality, it is a routine event in the vast universe, where the laws of physics operate in ways more ruthless and magnificent than anything humanity can conceive. The culprit behind this cosmic crime is none other than the black hole. An entity we often misconstrue as a deep, gaping pit, but truly, consider it the ultimate gravitational thief crafted by nature itself. The true essence of a black hole is a region of space where gravity is so intensely extreme that even light, traveling at 300,000 kilometers per second, cannot find an escape route once it has crossed the deadly boundary. Since light cannot reflect back to our eyes or telescopes, the black hole becomes invisible, lurking like a phantom in the dark cosmic ocean, patiently awaiting its unfortunate victims. Despite its masterful concealment, its domineering gravitational force is impossible to hide, akin to an unseen hand stirring a tranquil lake. When a wandering star inadvertently drifts into this gravitational sphere of influence, its fate is sealed by a phenomenon astronomers call a tidal disruption event. First, the hapless star is gripped tightly by the immense gravity, and because the pull is far stronger on the side closer to the black hole than on the farther side, the star is agonizingly stretched and shredded into countless fragments, elongating like a gigantic noodle strung across the cosmos, a process scientists vividly term the spaghettification effect. The scorching streams of matter from this shattered star do not plunge directly into the black hole's core but instead spiral around its rim, forming a brilliant accretion disk. Here, the debris collides and frictions against itself at terrifying velocities, heating the material to millions of degrees Celsius and emitting intense X-ray bursts along with powerful light, much like the star's final scream before eternal vanishing. It is thanks to this radiant glow from the accretion disk that humanity's advanced telescopes, such as the Event Horizon Telescope, have captured the shadow of a black hole, providing irrefutable evidence of their existence even though we cannot gaze directly into the heart. Recent observations, including those from the James Webb Space Telescope, have even confirmed instances of runaway supermassive black holes hurtling through space at speeds up to 2.2 million miles per hour, leaving trails of newly formed stars in their wakes, adding a layer of dynamism to our understanding of these cosmic wanderers. But the question arises, why do black holes possess such fearsome power? It all stems from the tragic demise of massive stars, the kings of the heavens. The larger a star, the steeper the price for its splendor, as it burns through its nuclear fuel in the core far more rapidly than smaller stars, resulting in a fleeting lifespan. When a supermassive star exhausts its fuel, the nuclear reactions in its core no longer generate sufficient pressure to counteract its own gravity, leading to a total gravitational collapse. The outer layers crash inward at dizzying speeds, producing a dazzling supernova explosion. And if the remaining core is massive enough, it continues to contract, shrinking indefinitely until that enormous mass is compressed into an infinitesimally small point with density approaching infinity, where all familiar laws of physics break down and surrender. This is the birth moment of a black hole, with its heart being a singularity concealed deep within. In a groundbreaking discovery reported in February 2026, astronomers witnessed a star in the Andromeda Galaxy, named M312014-DS1, transform into a black hole without a supernova explosion, a so-called failed supernova, providing the most complete observational record of this quiet collapse and suggesting that many black holes may form stealthily from stars as light as about 13 times the Sun's mass. The brilliant physicist Albert Einstein described in his general theory of relativity that gravity is not merely a pulling force but rather the curvature of the four-dimensional fabric of spacetime. The greater an object's mass, the more profoundly it warps the space around it, much like placing a heavy iron ball on a rubber sheet. In the case of a black hole, this curvature is so extreme that it forms a bottomless well, an eternal abyss encircled by an invisible boundary known as the event horizon. the point of no return. Any matter, be it gas dust, planets, stars, or even another black hole, that crosses this threshold is forever barred from re-entering the outer universe. Black holes are indiscriminate devourers, consuming everything in their path to increase their mass, evolving into supermassive behemoths that reign at the centers of galaxies. So, what truly lies within that profound abyss? Could it be a gateway to a new universe? A space-time tunnel known as an Einstein-Rosen bridge connecting different dimensions? Or simply the terminus of all matter? The eminent physicist Stephen Hawking devoted his life to studying them and proposed the concept of Hawking radiation, suggesting that black holes are not entirely black but can emit quantum radiation and gradually evaporate over time. Though the enigma of the information lost in them remains a contentious puzzle to this day. Intriguingly, recent studies from early 2026 propose that mysterious, little red dots, observed by the James Webb Space Telescope might represent an early phase in the emergence of supermassive black holes, where these compact, red objects could be supermassive stars on the verge of collapsing into black holes, offering clues to their rapid growth in the young universe. Perhaps humanity will require many more centuries, or maybe never, to grasp the bare truth beyond the event horizon. However, one certainty we must acknowledge is that black holes are not merely the universe's most brutal destroyers but also its grand architects. The cradles that nurture and shape galactic structures. Scientists believe that at the heart of most large galaxies, including our beloved Milky Way, resides a supermassive black hole acting as a gravitational anchor, maintaining billions of stars in stable orbits around it. For instance, Sagittarius A** at the Milky Way's center, with a mass 4 million times that of the Sun, serves this pivotal role, and new research from January 2026 indicates it may have shone 10,000 times brighter just a few hundred years ago, hinting at dramatic past activity. Without these black holes, galaxies might never form or could disintegrate, and consequently, there would be no solar system, no Earth, and certainly no us to ponder them here. The universe out there still harbors countless grand mysteries awaiting discovery, and each answer we uncover unveils thousands of new, enchanting questions. If you feel your mind expanding and yearn to continue the journey of unraveling the overwhelming wonders of the vast cosmos, do not forget to join us in the stories to come, where the beauty of science always shines more gloriously and wondrously than humanity's richest imagination. Wonderful. I will continue this flow of emotion and knowledge, drawing you deeper into the paradoxes and terrifying beauty of black holes, where the boundary between existence and nothingness becomes the most fragile. Right at that hazy boundary, let us try closing our eyes once and letting our imagination soar freely, picturing the fateful moment when a stray star ventures into the forbidden territory of a black hole. This is not merely a physical collision but a tragic symphony of light and gravity. A dance of death that astronomers poetically name the tidal disruption event. Imagine standing at a safe distance to observe. You would not see the black hole as a pitch-black void but as a sphere of nothingness encircled by a blinding halo of radiance. As the ill-fated star approaches, the black hole's gravity does not act uniformly across the star's surface but creates a terrifying disparity, with the pull on the facing side millions of times stronger than on the opposite. The result is that the poor star is not swallowed instantly but stretched apart, layer by layer, contorted into a glowing river of plasma snaking around the maw of doom, resembling a colossal luminous noodle amid the cosmic night. This process is so merciless that the matter from the star, as it is drawn into the accretion disk around the black hole, moves at speeds nearing that of light, generating friction so immense that temperatures soar to millions of degrees Celsius, unleashing high-energy X-rays screaming into space like the desperate final cry of a dying celestial body. But the most miraculous and unbelievable aspect lies in the experience of time, where Einstein's general theory of relativity asserts its absolute dominion. If you had a brave astronaut friend volunteering to fall into the black hole while you observed from afar, you would witness a ghostly phenomenon defying intuition. You would never see your friend actually reach the event horizon or disappear into the darkness. Instead, as they drew nearer to the edge, their image would slow down progressively, like a jammed film reel, until they appeared frozen eternally at the brink of the abyss. Simultaneously, the light from their body would shift toward a deep red due to the gravitational redshift effect, fading gradually until it dissolved completely into oblivion, leaving a haunting afterimage etched in the observer's mind. Yet, for the falling astronaut, the experience is entirely different. They feel no slowdown or freezing of time, their wristwatch ticks onward normally, but when they glance back at the outer universe, they might see the entire history of the cosmos fast-forwarding at breakneck speed, as if billions of years pass in an instant. And then, upon crossing the event horizon, the irreversible point, they confront physics' cruelest reality, the spaghettification effect. The gravity at their feet would be so much stronger than at their head that their body would be elongated vertically and compressed horizontally, transforming into a stream of individual atomic particles before merging into the singularity. That singularity, nestled at the black hole's center, is where matter's density becomes infinite. Volume 0. And every physical law humanity has painstakingly constructed over millennia collapses utterly. There, space and time are no longer separate concepts, they twist and entwine. Or perhaps cease to exist in the way our finite minds comprehend. Could that singularity be a portal to another universe? A wormhole bridging distant points in space? Or merely reality's dead end? The answer still rests in the shadows, challenging human intellect's pride. But it is precisely this mystery that makes the universe so alluring. We, tiny beings forged from stardust, stand on a blue rock adrift in space, striving with our limited brains to comprehend the infinity of black holes. Perhaps black holes are not monsters but the grand gatekeepers of the universe, safeguarding secrets about the origins and endings of all things, reminding us that no matter how far science advances, nature always reserves its supreme powers, untold stories awaiting courageous souls thirsty for knowledge to embark on the ceaseless quest of discovery. At their feet would be so much stronger than the gravity at their head that their body would be elongated vertically and compressed horizontally, transforming into a stream of individual atomic particles before merging into the singularity. In the language of astrophysics, we call this tragic yet poetic phenomenon the spaghettification effect. It is the universe's final warning: once you cross this boundary, there is no turning back. That singularity, hidden deep at the black hole's center, is where matter's density becomes infinite, volume contracts to zero, and every physical law humanity has painstakingly constructed over thousands of years collapses utterly. There, space and time are no longer separate concepts, they twist and entwine into a chaotic entity. Or perhaps cease to exist in the way our finite brains comprehend. Einstein once described gravity as the curvature of spacetime. But here, that curvature is so extreme it forms an eternal abyss, a bottomless well where all falling matter has only one direction and no return forever. But if a black hole is a perfect prison that allows no light to escape, why can astronomers photograph and study them? The answer lies in the meal of this monster. Black holes do not exist in absolute isolation, they are often surrounded by a brilliant accretion disk. When gas, dust, and the remnants of ill-fated stars are drawn in, they do not plummet straight down but spiral around the black hole's mouth at speeds approaching light. Imagine a cosmic firestorm where materials rub against each other, creating tremendous friction that heats this stream to millions of degrees. Right at this perilous edge, before matter vanishes eternally through the event horizon, it screams one last time by emitting the universe's most radiant high-energy X-ray and radiation bursts. This is the light that our Event Horizon telescope has captured, not the black hole itself, but its shadow cast against the backdrop of dying, blazing matter. Furthermore, a January 2026 discovery of a quasar in the early universe reveals a supermassive black hole growing at 13 times the theoretical Eddington limit while producing strong X-rays and radiojets, challenging models of how these giants accreted mass so rapidly after the Big Bang. So, where do these destroyers originate? The tale begins with the heroic death of colossal stars. Each star is a vast battlefield, where an unending tug of war rages between two forces, gravity seeking to crush the star inward and the pressure from nuclear fusion striving to blow it outward. When a star with a mass dozens of times our Sun's exhausts its fuel, the nuclear reactions extinguish, the fragile equilibrium shatters. In a fraction of a millisecond, gravity triumphs overwhelmingly. The entire stellar envelope collapses onto the core at harrowing speeds, unleashing a supernova explosion as bright as an entire galaxy. If the leftover core remains too massive, exceeding matter's endurance limit, it continues contracting, shrinking forever until it becomes an infinitesimally small point. Thus, a black hole is born, marking a star's end but opening a new enigma for the universe. However, it would be a grave omission to view black holes solely as voracious brutes. Modern scientists believe supermassive black holes are the universe's grand architects. At the core of most galaxies, including our cherished Milky Way, dwells a gigantic black hole. In the Milky Way's center, the black hole Sagittarius A*, with a mass 4 million times the Sun's, plays the role of a gravitational anchor, keeping hundreds of billions of stars orbiting in orderly, stable dance. Without them, galaxies might never form, and of course, there would be no solar system, no Earth, and no us here to contemplate them. Adding to this, observations from late 2025 and early 2026 have detected X-ray transients potentially linked to intermediate mass black holes tidally disrupting white dwarfs, offering glimpses into rarer classes of these cosmic entities. Could the singularity within be a gateway to another universe, a wormhole bridging distant points in space, or merely reality's dead end? The answer still rests in the shadows, challenging human intellect's pride, but it is precisely this mystery that makes the universe so alluring. We, tiny beings forged from stardust, stand on a blue rock adrift in space, striving with our limited brains to comprehend the infinity of black holes. Perhaps black holes are not monsters but the grand gatekeepers of the universe, safeguarding secrets about the origins and endings of all things, reminding us that no matter how far science advances, nature always reserves its supreme powers, untold stories awaiting courageous souls thirsty for knowledge to embark on the ceaseless quest of discovery. I extend my deepest gratitude to generations of astrophysicists, space engineers, and scientific researchers worldwide. Thank you for your silent dedication, extraordinary intellect, and boundless patience. It is through your sleepless nights at telescopes, decades-long complex calculations, and unyielding aspiration to reach the stars that humanity can lift the veil on the universe's mysteries, allowing us to better understand our place and cherish this miraculous existence more profoundly.